So we're going to add in the spacers and um, what? Uh, that's weird. Okay, we're gonna add in the spacers and screws and everything else. I think Marcus's computer like cut out or something because he just joined again. Okay, so we have these. Oh, that's not right, but okay. Marcus, are you having like internet problems or something? Got all okay. Okay, cool. Um, okay, so now what we need to do is add spacers and another plate so that these are connected, and then we can put it onto our other assembly. So I'll actually open up another thing. So what we want to do is put it into this assembly. And what I should have done was make the gearbox in the same document as this one, but I was doing them separately just to have them more clearly established. But I can import it to this document, so it shouldn't be a problem. Okay, but I'm going to finish this up first and then import that assembly. Right. So I guess what should we do first? I guess we can put in the spacers. So we know that this distance right here is like a little over an inch, and you can measure it just by looking at that. So we can make our spacers like 1.5 inches, just so that they're pretty well fleshed out. So we'll go back into our Gearbox Part Studio, add in another spacer, and this zoom thing, put it on the bottom. We'll add in another spacer, and we want the origin to be right here. And we'll add our same internal adder, like 3/1000 of an inch. And then we'll have our same 0.75 external diameter, and then we said 1.5 inches. And run it round. Sorry, not 0.75, 3/8. There we go. Okay. And then this hole should automatically be like, to move this again, 1.94, which is like tolerance for a 1032 bolt, which is 0.191 usually. Remember, because we added the tolerance on it. So I keep needing to move this around. But we can go back to our gearbox assembly and then import, insert spacers. And we should like name it usually is what we do, but that takes more time, but it takes some other explaining, so I'll do that a little later. I'll show you how to name all the parts correctly for a joint document. And then we want these in all the spots. So actually, well, not all of these holes, just the part where we want the spacers. And then we'll have it in one of the falcon holes. So we'll have a bolt going through. Just add all of those. And then I guess let's put these here. Okay. And these could even be like a little shorter, in my opinion. Again, 1.1. So maybe I'll even make these like 1.3 inches, which you can just go into the editor, shorten it up a bit, and then I'm just gonna add in airbox. It's loading. So we have that, but oh, my internet connection is unstable. That's not good. Okay. And what we also want is a bearing on the other side. Okay. We want these to face the same or opposite directions. Or I was going to say the same relative to the plate, but the way that you're going to want bearings typically to retain a shaft is to have both of them facing in opposite directions. So I could also have these with the flange on the outside on both sides. But in this situation, I just want them both on the inside. It really doesn't make too much of a difference, but I think in this situation, I just didn't want the flange interfering with the motors here. So I had them both on the inside. Okay, so you'll notice that there's this big gap right here. So if I don't put a spacer there, then this gear can slide up and down on the shaft. And I don't want that. So what I'm going to do is add in a spacer. And I put the bearing here first so that I can see how long I want the spacer to be. So I can just take that measurement and I can actually copy paste this measurement right here. And then, God, she is so loud. Okay, we'll just go in here, add in, I cannot see anything, a spacer. I keep having to move like the zoom thing around so that I can see all the different things. But when I move it around, it covers up different things. Okay. I want this to be 1/2 inch hex bore. Or, but yeah, okay. And then the external diameter, I want it to be 0.75. And then the length, I'll just put in the copy pasted number that we had. And I'll just flip this so it doesn't interfere with that part, and we can tell them apart. Okay. Now we have to move this back over, go back into the assembly, and then I'll insert this part. made it to that. Check. And it all lines up and good. Now the only thing we have to add into this part is a shaft. But this isn't quite the shaft length isn't going to be as simple as just from here to here, because this also needs to go into the wheel, and it also needs to go into the retainer thing, um, the bearing block. That's what I was going to say. So we're going to go into our MKCAD set, and then we want the Versa frame. And remember, we made the holes for this last time. Actually, not Versa frame, bearing blocks. No. What's a Versa frame? Or is it just Versa? Right. The thing we wanted was this one. Wait, no, not that one. This one. Because, let's check that. We want this to fit into the center hole part. Okay. But that's not the only thing we need. We also, oh shoot, you know what? I did not do this quite right. Oh, I needed to add in one more thing in here, and that is the double chain sprocket part. Okay, so, whoops. This is actually not on MKCAD, so I think we just have it in here. It's going to go in sprockets and chain, and it's this 16 tooth double sprocket. So the way that the drivetrains work is that they turn this sprocket, which has the chain on it, and it's going to turn the chain in a direction, and we'll only have a single sprocket on the other ends, and that way we can have a turn. Can have both of them turn. And I'm going to delete these mates here. Wait, this, this. This spacer should be good. We can keep that the same length, but I think we probably should have, these shouldn't be the same length. Okay, that is moving around. 1, 2, 3, 4. I'm just gonna end up having to delete these parts, which is fine, I guess. Okay. I still want this in here. That's not going to change. And then I'll actually just make this a 1/2 inch spacer, so it's a nice number. we still want this spaced a little bit so it doesn't interfere with the parts right here. We don't want the chain rubbing up against the gear or anything because it can tend to wobble around a little bit. So we can just go in and add this part right on here. So it's good. Okay. And then we also want another spacer. We can even add the same spacer just so that the chain doesn't interfere with the other side of the gearbox. So I can even just copy paste this. And then add it on. That's even a little wide. I might want to reduce down the chain, the spacer a bit. But that's like the general idea. You can like play around with the lengths. There's no fixed number that it has to be. It's just kind of make sure this all fits. And then what you can do is check the distance between these two plates. Now you can do that. And then we see that that is 1.97, whatever that is. Make that the length of the blue spacer. Add this here. Okay. So cool. Okay, what we want to do now is this part. Oh, and I don't know if I mentioned it in the last, or when we put in the stuff for this drivetrain, but the reason why we use these blocks on the outside and the different block on the inside is because this block only fits one bearing, and then on the other side it's retained by this bearing, or actually these two bearings. They're the shaft is. So when you put it on, it's not gonna like you don't need another one in there that's gonna rub up against the other bearing. So what you can do, you actually need like a little bit of spacing because this presses in to, I'm just gonna close this tab. This presses into this part. So it's not quite gonna be like up right against the, what's it called? The gearbox, because it's gonna be from this point to like wherever this is. Like that's wider than 1 inch. I think this to this. It's 9.9 inches. And then I'm trying to remember. Oh, we also need holes here for the for this piece, so that we can tighten it in into the gearbox and retain it on that side. So these holes are how far apart? 1.875. So we go back into our gearbox. And then make 1.875. And then these holes are gonna like a little bit conflict with the motor, but that's fine because we're not actually doing it on the side of the motor, and it's not going to affect it too much. Well, it won't affect it at all, actually. So, oh, that was not the right thing. Those, that, okay, that makes the holes. Cool. Okay, so essentially the bolt is going to be going through, it's going to be going through this plate and then into the gearbox to fasten it, if that makes sense. Yeah, so that's how this is attached. But we also want to just make this, I'm trying to work out like the math in my head for how this is going to go. It's been a bit since I've done this, but so if we put it in here, do right now is actually put the bearing on. And I guess right now what we can do is start putting in some bolts. So we'll show you, we don't actually have to download the bolts. We can just go into the standard content thing. So this is actually built into Onshape. We usually use inches for the bolts and screws. We typically use socket heads, or sorry, like these button head screws. Well, I guess they call them something different, but like you can see right here, this is a countersunk hole, so we would want something like that. These are actually 1032 volts, so I'm going to look for a different type. It's going to be like ISO, I think. No. Or is it inch? I'm just looking. Yeah, it's still inch. Okay, 1032. And this 1032 means that it's a number 10 bolt, which is like a certain size. I'm forgetting. It might be 10 millimeters. And it's 32 threads per inch. So like along this length, for every 1 inch of bolt, there's going to be 32 threads, which are like the little spinny things that go around the bolt. So I want to put a few of them right here. So like this one, this plate is a 1/4 inch thick, and then you only want it to go into the falcon by about like a 1/4 inch. So it could like really mess up the falcon if it goes more than like a 1/2 inch. So we kind of keep it light. So I really only want like a 1/2 inch bolt right here. So instead of the 1.5 the length, I'll just put 1/2 inch or 0.5. And I'll just insert. Oh, and you know what's fun is you can insert it here, and if it'll have like a few snapping places, and then it'll automatically mate to it, so you don't have to do that multiple times. So that's pretty cool. The bad thing is that it shows its mate connector, which can slow things down, but you can just delete those. And it can also be a bit frustrating to get it to work. Um, because it always likes to go in the wrong direction. Okay, there we go. Oh, and you can also do circular assembly patterns here. Um, I'm not doing that right now because this one is different and I don't want to deal with the whole getting the right angle thing for it. So maybe another time I'll show you those. But it's pretty much, I think we did linear assembly patterns, right? So it's pretty much the same as that. We did linear and circular patterns, and then, yeah. I'm gonna have to hide these parts. If you want to hide a part in an assembly just to make something easier to get, you just right click it. That's not the part. That's not even the hole that I wanted. Okay. And just stay here. And that's interfering with the bearing. So I'm actually not going to put that there. And that's why we do CAD, right? Because we can see that we don't want that hole there, or we don't want that bolt there, because it would interfere. Yep, that's the whole reason we do this, isn't it? Fun. Okay. Put this here. We'll just put them around the hole, around the circle. And give that a check. And we'll just right click this and hide the make connectors.
And does Onshape have a clash detection type of
Yeah,
feature?
it does. I can actually, I'll put in that bolt in this spot where I said I shouldn't put it, and then I'll show you how to use that. So if I right click, or sorry, not right click, but if I click both of these objects and then I right click on that and I say check interference, it'll show you the spot where it's interfering. Now, I don't know why it's not showing there. Well, usually it would be red, but this is a very small cross section, so you can't really see it. I can see that this is interfering, but usually I can show you a more obvious one. It's like, if this is like in the middle of this, it doesn't even have to be mated. I can like check interference, and then maybe it doesn't work with bolts. Yeah, so like that, you can see that it's interfering. I don't know why it wasn't working with the bolt, but maybe it's just assuming that that will go into parts and people don't want to see the interferences. But, or maybe what a lot of people do is just select the whole thing and then just check interferences for all of it. But that would like destroy my computer, so I'm not going to do that now. Okay, we also want a bolt going through this whole shaft right here and going into the falcon. So it's going to be like a ½ inch more than this. So this is 2.26, sorry, a quarter inch more than that. So we'll make it like 2.4 inches, 2.5. Mhm. See, this just goes all the way through, and it'll get the falcon, or it'll screw the falcon into place. And we don't really like, I'm not sure how many screws we use this year. We really only need like 3 of these. But I'm just putting it all just for fun, I guess. Um, hmm. this one, we want it to be retained on both sides. And actually, we would want a different spacer for that, but that's fine. Usually, we would make this like a tap size for 1032. I'm forgetting what number that is. I think it's 0.191, then the tap size is going to be a little smaller. I think it's like 0.175, but I do not remember. Actually, yeah, we can go and do that. I'll delete these spacers. I just copied them. That's not what I think to do. Like this. Okay. And then this is here when it should really be here, but I want, what is it? Another spacer. Go ahead and click that. No. Space here. External diameter should be 0 points. No. 0.8. And whoops. I'll take this measurement again because I accidentally copied that number instead of pasting this one. Okay. Go back to here. Get this space here. Call this 3/8. And then I don't like that it won't let you choose the internal diameter. So I might even just make a custom spacer. It's not going to let me do that. That's fine. I can just, but I'll use this center and then call this 8, and then this should be, I'm pretty sure it's 0.75, so sorry, 0.175 is like the tapping when you want the threads to contact. That should be the length. I may be wrong though. I hope not. I want this to be a new part. Make it that length. Okay. And then have that. Didn't take too long. That's good. This here. Copy paste it over here. I made it. I'm just now seeing that my something is broken. Oh, I didn't even realize I deleted that gear. Oh wait, no. It's because I hit it. Okay. Show all instances. And this is broken. Why? Actually, I'll just remake that. I think I must have deleted the part that it mated with, or maybe I over constrained it. Either way, it doesn't matter. Oh, there's an extra bolt here. Came from. The bolts. Okay, we're good. So now what we can do, we want this to go in about 1/4 inch, so we can also use the 1/2 inch bolts here. So we can go into our standard content and go back to the half inch. And then insert it here. And then here. Also on the other side. There we go. Okay. So we got all that done. And now we just have to get this thing in there. And then put the wheel on. Yeah, so we also want, we like blue nitrile wheels. Those are fun. So MKCAD wheels, I'll import one of those. You have lots of different types. We also like using the Omnis. I think I'm gonna go with. And some of these are rubber wheels, but we want the 4-inch blue nitrile with the half-inch X4 spot. And I can't remember. Yeah. So we want to group these so that they don't fall apart. And that's this. Okay. And then this is going to go maybe to this part right here. And a lot of times we'll add like a spacer between these two things, but that's usually something we do like afterwards, like in real life, I guess. We'll do it. But like right now you can see that it fits. So it's not too bad. And then what I'm going to do is actually hide this for now. That's not what I wanted, right? I was still in the matrix. Okay. Hide. Okay. Okay. So now what we want to do is put this onto this plate. And I think that just goes flat. But I could be wrong. Okay. And then we want a bolt going into this part. And since it's kind of difficult to tap these plates when they're so thin, we might even want to just put a bolt or a nut on the other side to retain it. So this is level, and I put these holes to 0.191, so it shouldn't be an issue, right? Yeah, okay. So this space to this one is 1.615, so we'll use like a 1.75 volt, maybe. I don't know, I'll try some things out. But for this one, we want a, not a socket head, but a countersunk bolt. And then, let's see, 1.75 is what they're giving me. I want the flat head. Oh, right. And then this mating thing never works with countersink bolts. That has been an issue in Onshape for a while, but you know, it's whatever. I guess it doesn't show the head here. That's fine because we have countersunk bolts with hex for outputs. And that goes how far in? Not too bad. Okay. We'll just do this. And then right here. No, that's not what I wanted. It's right here. And then goes to this. Yes. Okay. And then is this not? That's weird. Maybe I didn't make these holes perfectly tangent. Sorry, not tangent, but perfectly horizontal to the center. Um, I'll just redo them, I guess. What I want, circle this, and this should be horizontal. Mirror that over. Okay, that should be good. Yeah, okay. So now what we want is a 1032 nut to come on the other side. And a nut is the thing that you put on the other side of the bolt to uh, obtain it. So we want a hex nut and make it what? Do they not have the 1032 nuts? 7/16. Okay, I think this one is usually the right size. Or we usually go with like a 7/16 bolt or um 7/16 wrench to deal with these nuts. That is huge. That's all I wanted. I don't understand why this is not working. Um, X not 7/16. No, still massive. Okay, we can leave the nut for now because we know it goes there. Um, it won't interfere with the bearing. I don't know what's up with that. I could have sworn there used to be the other kind. Mm-hmm. And what else we can do is also put a spacer here so that the bolt isn't interfering there, but that isn't as important at the moment. Um, what else? Oh, we can. I need to test to see if this is the right length. 1.24. That's the first time I've had it be like more than it should be. That's weird. Okay. Well, it's fine. Parts, and now we can figure out the length of the hex shaft, even though it's not the right spacing. It's here, here, no. Okay, wait. I had these gearboxes open. I'll take a look at one of these. All right, you do it the same way here, and then you just slip the thing on top. to press into the gearbox. Mhm. Maybe I can look at some older things that I've done. But essentially, the thing is going to go into this piece. It should go all the way through, and then the gearbox plate is supposed to be right up against this plate right here, so that there's no like jiggling around or anything. So I think I've made a few of these, or a lot actually. And then so we can actually look at old. Um, did I do this differently? Oh, I didn't even add on the thing for this one. Um, okay. Um, okay. I guess we can look at our robot things here. Um, this is not the right. Okay, well, just open this one up again, and then can just leave this like it is. I feel like I'm missing something, but I don't think I am. This just goes right in. Okay, well, let's go in here and then insert from other documents. You can go into your own on-shape thing. And did I make this in a, I made it in a folder. No, screen training, which is not letting me access. Great. I'll just make a copy of it then. We're going to go into assemblies and insert it here. And I want to mate like one of these, and then that's not that. I want to mate this round part to this face. Okay, I'll just put that there. And we have our thing. See it, this is going in, and it's a little offset there. It's not exactly what I wanted, but you can mess around with that. I think even we can make it like so that this goes all the way through instead of the bearing. but we'd have to mess around with the thing a little bit more. Okay, so I think what the issue is that this isn't supposed to be here because it's supposed to retain from this bearing and not go through 3 and only go through 2, if I'm remembering correctly, which is confusing because the way they do it here is with this bearing going the opposite direction. But it's not usually supposed to be like that for the output shaft, I think. Unless I did this completely wrong. But let's delete this. And this was mated there. And then what I can do is make this piece from here to like here. And then I want to offset this by like 1/10 of an inch. Oh, okay. Now I remember how to do it. Okay, yeah, okay. So you want this shaft, this spacer right here is supposed to go all the way up to that bearing. Right here. Okay. But you also want to offset this by like 1/10 of an inch because it's not quite the right distance. Okay, right. This is okay, 1 point, or maybe it was 1/100th of an inch or something. I can change that though. Okay. So now if I look at this, perfectly on 1 inch. Um, okay. I want these bolts to be different sizes now, though. So hide this again. And then that's 5 screws, countersunk, 1.5. This might not even be long enough, but I think it should be. Does it? Okay, that's actually that's pretty perfect. That's exactly the length I wanted. Okay, so now we have these in here. We can show again. So we have this whole thing, and then if we go in here, then I still need to refresh this. Okay, what happened here? That's not right. Okay, actually, I'll just remove this and then insert it again when we're fully done with the thing. Makes me think, is one of these not mated? Oh, okay. That's a mistake. Okay, there we go. Yeah, there's always going to be like mate errors. That was not right. Okay. But what I usually do is just delete the mate and then see where, or I'll see where the mate is like broken. And then if you can fix it, that's great. If you can't, you can just delete it and try it again. Because like I think the most common thing that happens when there's like a red mate that's broken, it's almost always because like you accidentally deleted a part that it was mated to. So the make connector doesn't exist anymore. So you pretty much just have to put that make connector back in and have it be done. Okay. Now I need another spacer here.
Another question, Ben.
Yes.
Can you select a part and see all the parts it's mated to before you delete it?
Can you?
I don't know.
I think you might be able to. You can show the mates on it. So I can see like this is mated here, right? Or even on this, I can show mates. Yeah, so you can see all the different things if you want to. So yeah. Okay, now what we need to do is make a spacer that's going to go from this all the way up to that bearing, this bearing right here on the other side. So it's going to go through this part, and it will be pretty long. And this is like a pretty difficult measurement to take because you can't really like touch the other side of this thing. So I'm just going to hide this, I think. Yeah. So go from here to here, 1.525. Excellent. And then again, if I go in here to make a piece or a spacer, or flip that. And then I want this to be half-inch hex. And add a little bit, and the external diameter will be 0.75. Check. And we'll insert that into our assembly. Right here, and then this should be retained. Check it out here. It's all good. Okay. Right. Oh, and now we put in the shaft. So if you look here, you can see like a big hex hole that doesn't line up. That goes through the gears and or the final output gear and the spacers and the bearing on the other side. So what we can do is insert a hex shaft here. So I want to take this final length right here, which is like that much, and copy paste that measurement and go make a uh, shaft. Call it origin right here, half-inch hex. For the retention type, in this situation, we want the shaft collar because we just want it to be the thing. Sorry, no, not the shaft collar. We want it to be the retaining ring, which is like a little, well, I'll show you. We'll put it in. We want the same retention on the end, and we'll just chamfer it because why not? And we'll put that in as the effective shaft of it. And check. No? Doesn't want to. Oh, unless it's selected the wrong thing for origin. That's usually what it likes. Is this broken? This is acting very strange. Okay. I think the feature script might be broken right now, but we can just make it ourselves if we want. Which is kind of annoying, but whatever. Okay, I have to remember how to do this because I haven't done it in so long. Wait, actually, I'm gonna try and download it again. This was the really slow one. Okay. Well, uh, anyway, we would pretty much just go in here and then add in. We can make our own shaft, I think, which is going to be difficult, but not too difficult because I don't know. Okay, that's not what I meant to do. Let's make a sketch and have a polygon, and I'll make it. I don't want it to be touching these things. Okay. Six sides. Oh my god. Thank you for yelling right into me. Okay. And then I'll make this side length a ½ inch because that's right. Yeah. Okay. And then for right now, um, we can just extrude it a little more. And there's like a way to do this, but it's touchy, I guess. I'll just put that. What's it doing? Okay, so this is our shaft, and what we want is like these little rings for the shaft retainers, but that takes some more measurements, and I have to like look up the lengths of the things, and just take a while. So for now, I'll just put this in as it is. That and finish this up. Well, yeah. So we have it, and on the other side, and then we can essentially just pop it into our thing now. Insert a gearbox. Um, this before. we want to version it because that's what Onshape likes. Okay. And we just put that in there. And okay. And then there's this issue too. But okay, that's essentially the end of our gearbox. That's all we really have to do. And I guess we're pretty much done. So I'll stop the recording,